Hi everyone, Kittyman74 here. Well, it goes without saying that COVID has disrupted all our lives. Well, I can't imagine what it's like to be preparing for national exams now, so I'm starting this channel to just share my mathematics experience and thought process with you guys. So, this channel really isn't about me or my face or my personality, it's just straight up content. So therefore, I'll keep the videos as short as it is necessary. Today, I'm starting with the last AMATS topic, kinematics. Let's go. Okay, so if you have done a bit of revision or a bit of reading up, this kinematics question is from November 2019, and this is paper 1, I believe. So question 11, this kinematics question is it's about a simple polynomial. So first off, this dot moving in a straight line, and it just left O, so the displacement is this equation, okay? The standard equation. So as always in kinematics, if you see something instantaneously at rest, it means the velocity is equals to 0. So if we want the velocity, straight away you just go for a simple derivative of s, and we get 3t square minus 12t plus 9. Okay, that's how we get the velocity. Just differentiate the displacement. So instantaneously at rest, that means v equals to 0. So when dot is instantaneously at rest, v equals to 0. So we're going to have 3t square minus 12t plus 9 equals to 0. So this question really isn't about how you solve this quadratic equation, but at this stage of your revision, factorizing this in one step shouldn't be too difficult for most of you, right? So we're going to have a minus 3 and minus 1, okay? So if you like just a bit more time to work on this, just go ahead. I divided by 3 for everybody, so it's t squared minus 4t plus 3, and then simple factorization would give me t minus 3 multiplied by t minus 1. So I'm going to say, therefore, t equals to 3 or t equals to 1. Done. That will give me 3 marks. Okay, so if you didn't write the sentence when dot is instantaneously at rest, v equals to 0, right? You would need to have a final concluding statement which says that you understand what you've just found refers to the time when the dot is instantaneously at rest. But for me, I prefer writing out statements at the start. So I write when dot is instantaneously at rest, v equals to 0. So that saves me some trouble at the end. But it's up to you how you want to do it. This is my recommended way. Okay, so find the acceleration of the dot when it first comes to instantaneous rest. So it implies that, so when dot first comes to instantaneous rest, when dot first comes to instantaneous rest, t is, oops, pardon my handwriting, part instantaneous rest, comma, t equals to 1, because this, we've got it from the previous part 1. So for acceleration, right, again, it's another simple derivative of the velocity, and then we should have equals to 6t minus 12. So when t equals to 1, acceleration will be negative 6 cm per second square. Please take note of your units, because here they didn't ask you for the value of the acceleration. They wanted the actual acceleration, so that's why you had to include the cm per second square. So if you contrast it from part 1, right? Part 1 they said the values of t. So these values here, t equals to 3 or t equals to 1, it's not required for the unit seconds. I hope that's clear for everyone. Okay, so now this is kind of a bit more interesting. Explain clearly why the total distance traveled by the dot in the interval t equals to 0 to t equals to 4 is not obtained by finding the value of s when t equals to 4. And you're given 2 marks for it. Well, this one, 2 marks explanation isn't that straightforward actually, because I know most people would just write, most students at least, they would just say when the value of s when t equals to 4 gives the displacement of dot from O, but not the total distance traveled. So I'm not really sure if in the marking scheme that SCAB has, they would give you 2 marks just for writing this sentence. So I think it's really safer if we illustrate by a simple diagram. So for example, this is my S for displacement. I'm going to say it's not to scale. Not to scale. Just be very careful. Oops, I'm sorry. S, not to scale. So at the start, you're at 0. And this is some other distance which we haven't found out. So for example, this particle started at O, and then, sorry, the dot, I mean, it moved across the screen, and then at t equals to 1, it made a turn, right? Remember in O-level kinematics, when I say something is instantaneously at rest, it means the velocity is equals to 0. So if the particle or the dot continue its motion, right, it means the dot has to reverse its direction of motion, which means it's going to turn and be over here at t equals to 3. So finally, t equals to 4 would be over here, t equals to 4. I mean, I don't really know what this value is because we didn't really find out. So that's why I said this is not to scale, and I just made a guess that those distances are equal, but it doesn't really matter where you end your lines. So this is the diagram to illustrate my next point. So my next point is that, let me just go back to my black pen. My point here is actually, oops. Yeah, my point here is, so to find the total distance, right? To find the total distance, traveled, we need to sum up the distance traveled from t equals to 0 to t equals to 1, then t equals to 1 to t equals to 3, and finally t equals to 3 to t equals to 4. So if you thought this explanation is kind of excessive, maybe, but I was a Kiangsu student, so now I'm a Kiangsu teacher too. So any chance that we can grab hold of the marks, you shouldn't let go of it. If you know more, just write a little bit more. It doesn't take you too much time, but it can give you it can give you a much better score. So now having done this explanation, right, we know that we need the total distance as the sum from t equals to 0 to t equals to 1, t equals to 1 to t equals to 3, and then t equals to 3 to t equals to 4. So now we want to find the total distance traveled. So let's say, so displacement, right? So when t equals to 1, s would be equals to, remember the equation all the way at the start, t cubed minus 6t squared plus 9t. So s equals to t cubed minus 6t squared minus 6t squared, sorry, I just suddenly forgot, minus 6t squared plus 9t. Okay. Wait, sorry, this presentation isn't too good. I apologize. Sorry. So anyway, sorry, never mind. My OneNote seems to be a little wonky. So if you do the substitution correctly, you know this is 4 cm. So when t equals to 3, s would be equals to 0. So actually, incidentally, right, the particle is back at the starting point at O. So do the same for t equals to 4. You realize that s equals to 4. So now it should be clear, right? This point here is actually 4. This point here is actually 4. So therefore, total distance traveled from t equals to 0 to t equals to 4 would be 4 plus 4, because the particle traveled 4 cm from t equals to 1 to t equals to 3, plus this final 4. So that will give us 12 cm. So this question isn't really that hard, but you need to figure this out. This is the crucial part here. To find the total distance traveled, we actually need to sum up the distance traveled from t equals to 0 to t equals to 1, t equals to 1 to t equals to 3, and t equals to 3 to t equals to 4. So just remember in next time when you have encountered kinematics questions, right? Always check this. Did the particle turn? So in general, right, if you see a displacement equation that is a polynomial, t cubed minus 6t squared plus 9t or some other quadratic form, right, there's a very high chance that the question will get you to find out when the particle is turning. So the moment the particle turns, and if you are required to find the total distance, you need to be very clear that the distance is not simply the displacement. Okay, so that's it for this question. So another kind of very typical kinematics question, right, is they like to give an exponential function. So this question is from November 2018, paper 2, question 7. So, sorry, excuse me. So this one, well, doesn't look too difficult because exponential differentiation, exponential integration actually isn't that hard. But this one, the numbers look rather ugly, you know, like there's a e to the power of negative t over at. So the constants, you've got to be very careful with the constants later on. So just remember that the girl cycles up this hill past a fixed point A. So, and the distance that she cycles in t seconds after she passes A is given by this equation. So, find the girl's speed and the acceleration 10 seconds after she passes A. So, if you have your d as that expression, so to get the speed, so we're going to say write down speed will be equals to d, well, the d, I mean, because in this question they use d, they use the distance as d, so we have to follow the notation that the question gives us. So d looks kind of strange, I'd agree, but not to worry. Just make sure we do the correct differentiation. So 840, it's still there. So because I'm starting with this kinematics, I'm assuming that you have a proper foundation in differentiation and integration already. So this differentiation shouldn't be too challenging. So if you differentiate the constant inside 1, you get 0, nothing. So negative e to the power of negative t over at, if you differentiate it, you need to multiply by the constant in front, which is negative 80, negative 1 over 80, I'm sorry, negative 1 over 80 multiplied by itself. Always remember, if you differentiate an exponential, right, you'll get back yourself first. Just write it down. You get back yourself, and then you need to multiply by the constant, the coefficient of t in the expression. So always remember that. Then I'm going to close this bracket, minus 2. Okay, because you differentiate 2t, you just get 2. So that's not too difficult. So 840 divided by blah blah blah, I will be getting, I'm sorry, I just missed out the negative here. When you differentiate exponential, you get back yourself, including the sign in front, and then multiply by the constant, which is the power of the coefficient of t here, negative 1 over 80. So if I do the multiplication correctly, this one would give me 21 over 2 e to the power of negative t over 80 minus 2. So when t goes to 10, speed will be equals to 21 over 2 negative 10 over 80 negative 1 over 8 minus 2. So I'm not really sure if you can leave it in this form, but if you just want to play safe, please round off your answer to 3 significant figures, which would give us 7.27. This one is in meters. So if you read the question carefully, the distance is measured in meters. So the speed will be meters per second. Okay? 2, 3 significant figures. Please don't forget this. All right. Now the acceleration. So I didn't give a symbol for speed. So, let's just be consistent here. Differentiate speed with respect to time. So again, if you know how to differentiate just now, differentiating this shouldn't be a problem too. Differentiate exponential. The 21 over 2 is still there, I'm sorry. differentiate exponential, you get back yourself. Just write this down first. And then you need to multiply by the coefficient of t here. Actually, it's the derivative of the power, but to keep things simple over here, it's just the coefficient of t, negative 1 over at. Close bracket. Differentiate 2, you get 0, so there's nothing left. So this one we would get negative 21 over 160 exponential negative t over at. Again, do the substitution. When t equals to 10, acceleration equals to blah blah blah. When you make your substitution, you will just get negative 21 over 160 exponential negative 1 over 8, which gives us negative 0.116 meters per second square. Again, that answer was to 3 significant figures. Okay, so that wasn't too hard. Part 1, you've just gotten 6 marks just for doing a very simple exponential differentiation and substituting in the number. Bam, that's it. Okay, part 2, explain what the sign of the acceleration indicates. So you realize that the sign was negative. So you're going to write down, since the sign of acceleration is negative, it indicates that, or you can say it means that, her speed is decreasing. Well, simple sentence like this, 1 mark. Well, not too bad. It's kind of worthwhile. Okay, now maybe it's a bit interesting. When she reaches point B, her speed is 1.5 meters per second and she gets off her bicycle. Given that A is 500 meters from the top of the hill, calculate the distance she has to push her bicycle to reach the top of the hill. So, if you're a more visual person, maybe a simple diagram would help us over here. So this one, she's obviously going up an incline, right? And this is 500 meters. And then A is at the bottom of the hill. If you read the question carefully, this question is with respect to this point A. So A is at the bottom of the hill, and then top of the hill is here. B is somewhere here. We don't know where. So calculate the distance she has to push her bicycle to reach the top of the hill. So actually we are interested in this one. Okay? So that really isn't too difficult. So you just have to find out when at what time she reaches point B. So we know that at point B, right, her speed is when V is equals to 1.5. I apologize, I didn't define V, I didn't define acceleration here. So technically speaking, if you didn't define any symbol, right, you can't use it. It means that if you want to use something that is not defined in the question, you need to define it on your own. So you need to be strict with yourself. So over here, right, nobody defined V, nobody defined acceleration for us, and I didn't do it. So here I should keep to speed. When speed is 1.5. So 1.5 equals to 21 over 2 exponential negative t over at, subtract 2. Sorry. So 3.5 times 2 over 21 equals to exponential negative t over at, then negative t over at. We're going to take ln on both sides, equals to, let's see, what do we have? 1/3, I think. Negative t over 18 equals to 1/3. Then when I ln it, you'll be ln of 1/3. Okay? So t will be equals to negative 80 ln 1/3. So don't be afraid that you are getting a negative number here, because actually ln of 1/3 is a negative number. So when you multiply by negative 80, it's actually positive. So time should always be positive. You always go forward in time, right? You can't, go back to the future. So yes, so this t is a positive number, don't worry. So now we need to substitute in the distance. Sorry, substitute this time into the distance. So if you remember, d was, so we're going to say when t goes to negative 80 ln 1/3, this distance will be equals to 840. So if you can't remember, let's just scroll it up. 840 multiplied by 1 minus exponential negative t over 80. 1 minus exponential negative t over 80. So t over 80 plus, minus 2t. So I trust everybody, has good enough calculator skills. But I mean, because by the time you reach Sec 4, right, you're pressing in calculator, substituting in the correct power for exponential shouldn't be a problem for you anymore, right? So I'm just going to skip all this and tell you the distance is 384.22 and so on. I'm not going to care so much about how many decimal places there are, because my final answer, the final thing that the question wants, right, is distance she has to push her bicycle to reach the top of the hill. So in my final statement, right, always remember your statement, guys. Always remember your statement. Therefore, distance she has to push the bicycle will be 500 subtract 384.22. I mean, I just put the answer, the previous part, I just found it as 5 significant figures, so that when I round off at my final answer, the 3 significant figure answer will be accurate. So 116 meters, and also, as always, remember to write down it is 3 significant figures. Significant figures. Okay, that's it from me today. So I realized this question has been, these 2 kinematics questions has been about differentiating, because we have the distance and the displacement. So maybe in my next video I'll find some questions which actually require the use of integration, or if there's any other topic that you guys would prefer, please let me know too. So, well, if this video has helped you, please remember to like and subscribe and tell all your friends about me. And as always, have a kitty nice day. Stay safe and work hard. Thank you.